Chapter 3, Coordinate Geometry. Let's look at what we have to cover in coordinate geometry. Again, it takes you back to IGCSE concept. But let's quickly look at the image. When was the first time we started using the plane, if I could ask that? It takes us back to the 1920s. Airlines have been trying hard in terms of maximizing their profit by selling some tickets, maybe at some discounted rate, so they could fill seats that would otherwise not have been sold. But how many seats should they sell at the discounted price? Or how will we look at the revenue management in terms of this problem? And that is where coordinate geometry is very important, because the idea and the techniques of coordinate geometry can as well be used to solve this problem. Coordinate geometry also solve issues like linear programming, and this include formulating and using equation of the straight lines and graphing them on coordinate axes. So ideally in coordinate geometry we are going to look at equation of a straight line giving sufficient information. That will be objective. Let's quickly look at it. We need to find the equation of a straight line giving sufficient information, and we also need to interpret and use any of the form of the equation that we know. By now we are used to the equations of a straight line. We know we can have y equal mx plus c, equation of a straight line. And then we can as well use the equation in which only one point is given. We can have y minus y1 equal to m into x minus x1, where m represents the gradient of the line. So all this concept is what we are going to look at in this particular topic. Understand that equation x minus a, we have equation x minus a, and if we add y minus b and we square both sides, so it is x minus a squared and y minus b squared. So this equation represents r squared in terms of the circle with center AB. So this is equation of a circle. So we are going to look at this concept and how we are also going to find r, where r represents the radius of the circle. We are also going to use algebra method to solve problems involving lines and circles, understanding the relationship between a graph and its associate algebraically. So this is algebraic method of solving some equations, and how to use the relationship between the 2 points that is given of the intersection of the graph and solutions of that given equation. Conceptual understanding. What do you know in terms of equations? Is it equation of the line, equation of the perpendicular line, and equation of the parallel line? What do you know? Test your understanding. We are going to go back to Pythagoras theorem, how to find the length of a third side of a right angle triangle given two sides. So here we have two sides ABC. You can see this is a right angle triangle as it is indicated. So we have a right angle triangle here, as you can see, right angle triangle, and A is given as 2 centimeters and B is given as 3 centimeters. We are supposed to find C. We are supposed to find C. By Pythagoras theorem, we know conceptual understanding. A squared plus B squared is equals to C squared, right? So we have C to be equal to a squared plus b squared, our a squared is going to be what? 2 squared plus 3 squared. This is c squared, right? So what is 2 squared? You will get 4, right? So it is 4 plus 9. So c squared is simply what? 13. So how are we going to find c? We take the square root of that. So what is the square root of 13? You will simply get decimal 3.61 centimeter. And that is exactly what happens here. So we have 2 centimeter and B 3 centimeter. We are to find C, conceptual understanding, IGCSE. So you are able to take by Pythagoras theorem a squared plus b squared equals c squared, and from there we are able to determine the value of C, which is 3.61. Try again to see how to find a gradient of m in this equation. You have y equal 3 minus 2x. So these are concepts that you should know before we dive into coordinate geometry. Try to check your skill. How do you find the length of the third side of this triangle? So we have our triangle with side ED and T, ED and F. This is side F, and you are given D and E. So you simply square both sides. It becomes 3 squared plus 5 squared will be what? We know 3 squared will give you 9. 5 squared will give you what? 25. So what is 9 plus 25? So 9 plus 25, take the square root of that. This is supposed to give you what? What is F? Conceptual understanding. Try and attempt and check your skill. Test your understanding as we dive into coordinate geometry properly. So 3.1, the first thing we want to look at in coordinate geometry is line segment. We want to look at line segment. So look at this line. Look at this line that we have. Let me try to enlarge that so that you can see that line. If I enlarge this line, you can see that line. Look at that line that we have. You can see that, right? So if you have the coordinates of the end point of a line segment, we can find the midpoint of the line. In this line coordinates, you can see this Cartesian plane. We have y-axis and x-axis. Point A is having coordinate 1 and 5. From 1 up to 5. Like you can see here, you have 1 up to 5. This is point 1. And then it goes to 5 around here. 5. And point B, M here, represents the gradient, the change in y in respect to x, change in y over change in x. And we have B, coordinate B is 7, 1 along the y-axis, right? So we already have the coordinate of A and the coordinate of B. So we can see from the diagram that the coordinate of the midpoint of that line AB is simply 4 and 3. 4 and 3. The midpoint, it is 4 and 3. Right. The x coordinate is halfway between x equal 1 and x equals 7. The y coordinate in the other way is also halfway between y equal 1 and y equal 5. So therefore, for us to find the midpoint, we are going to apply the formula x1 plus x2, divide this by 2, right? And then y1 plus y2, divide this also by 2. So this is the formula we need, the midpoint of the line joining x and y. That is x1 and y1. And then we have x2 and y2. So we are going to apply this formula in order for us to compute. So if we look at the graph and try to solve, we can see here that if we take 1 plus 7 as our x1, 1 plus 7, x1, 1 plus 7, this gives you 2, right? 1 plus 7. So 1 plus 7 divided by 2, that is 8 divided by 2 gives you 4. And then 5 plus 1 divided by 2 gives you what? 3. So that's how we get the midpoint as 4,3 as the midpoint. Again, for us to find the gradient of the line joining x1 and y1, we can use y2 minus y1 divided by x2 minus x1. And we can find the gradient changing y over changing x. So you are doing the run. So you go, how steep is the object? Change in y over change in x. Again, we can find the length of the line segment between those two values by taking the square root of the two numbers. This takes you back to Pythagoras theorem. And this is the concept that we are going to cover in this particular topic. So let's take the first example. P has coordinate -5, 4, and Q has coordinate -3 and -1, right? Find A, the gradient of PQ. The gradient of PQ. What is the gradient of PQ? Let's check that out. The gradient of PQ. B, find the length of PQ and the coordinate of the midpoint of PQ. Wow. Okay, so let's look at the first one. We want to find the gradient of PQ. So gradient M, gradient is always written small m. Capital M will represent the midpoint. So the gradient will be change in y over change in x. Change in y over change in x, right? So we have our x values and our y value. You can decide to write them down. Our x1 in this case is -5, and our y1 is +4. x2 is -3, and our y2 is -1, just like we can see them here, right? So the change in y over change in x would be -1, -4. -1 is what? y2 minus what? y1, right? So it is -4, -1, -4, divided by x2 minus x1. x2 is -3. So it is -3, negative, then -5. So what is -1, -4? -5. So we have -5, -3, negative becomes -3 plus 5. So that is simply -5/2. Right. And what is -5/2? Simply -5/2. So -5/2 is the gradient that we are looking for. Okay, so now let's look at the second one, the length PQ. B, we want to find the length. We want to find the length. The length PQ. The length PQ is nothing but the square root. So we can take the square root of -3 negative negative 5, right? Then we square this. Plus, by Pythagoras theorem, negative 1, negative 4 squared. So we take the square root of all of this. So that means that what we are going to get, if we have negative 3, negative negative 5, that will be positive 2. So we take positive 2 squared. Positive 2 squared plus negative 1 negative 5, negative 4 gives us negative 5. So it is negative 5 squared. So we are going to have the square root of all of this. So 2 squared will give us 4, and we have 5 squared is 25 plus 4, that is 29. So what is the square root of 29? The square root of 29 is going to give us 5.385, correct. So this will be the length of PQ. C, you are to find the coordinate of the midpoint. The coordinate of the midpoint. So we do y1 plus y2 divided by 2. Then we are going to have negative 5 plus negative 3. Divide this by 2. And then we have negative 1 plus 4. Then divide also by 2. So this is the formula for us to be able to find the midpoint, capital M. So this becomes negative 4, because negative 5 plus negative 3 divided by 2 gives us negative 4. And then we have a half, 1.5. Negative 1 plus 4 by 2, 1.5. Correct. Very simple. Look at now. Test your understanding. Test your understanding. Test your understanding. Kindly check the answer that we have just solved. Example 2. The midpoint M of the line AB has coordinate negative 3 and 1. B has coordinate negative 1 and negative 2. Given that a point C has coordinate 2, 5, find the exact length of the line AC. I want to believe that you guys are still in class. Yes, someone to read for me. Read for me the example 2, the midpoint. I want to believe you're in class.
Yes. So the question says, the midpoint M of the line AB has coordinates negative 3, 1. B has coordinates negative 1, negative 2. Given that a point C has coordinates 2, 5, find the exact length of the line AC.
So you can start by drawing. You are able to draw. And when you draw, a kind of a sketch, a useful sketch that can help us illustrate what we mean when we talk about those two lines. So according to the information given, let's try to sketch this. So we have, it is a midpoint of line AB. So we can have our line AB here. So this is line AB, right? And we can take the midpoint to be M, the midpoint. So this is the midpoint, capital M. Right, so M is given as negative 3, 1. Negative 3, 1. Coordinate B is, we have negative 1, negative 2. Is it negative 1, negative 2? According to the information that we have, AB has coordinate negative 3 and 1. So we are looking for the exact length, the exact length of the line AC. Well, if we are looking for the exact length, we can let simple algebraic expression. So we can let A be the midpoint, right? So if A is the midpoint, we can let A to be the capital M, meaning it is the midpoint of X and Y, right? Then X minus 1, so it is X plus minus 1, divide this by 2 will be equal to what? -3, such that we are able to find what is X. So X is going to be -5, right? You simply have to multiply that. X is -5. Also, we can take Y plus -2, divide this by 2. This is going to give us 1, right? Because we have the midpoint -3 and 1. Such that our Y value by computation gives you 4, right? So if we have 4 and -5, then we can say that our A value is nothing but -5, coordinate -5 and 4. And then we have point C, which is 2 and 5. 2 and 5. So the length of this line will be the square root of that. So length AC will be 2 minus -5 squared. Plus we can have 5 minus 4. 5 minus 4. Square this. So all this under the square root, right? Such that we are going to have this becomes 1 plus 49. 1 plus 49. 1 plus 49 under the square root gives you 50. So what is the square root of 50? The square root of 50, you just have it as root 50. Yes, correct. Root 50, or it can as well be 5 root 2. 5 root 2. But you can leave it as root 50 or simply 5 root 2. Now, test your understanding. Test your understanding in the next question. You can see the answer here is root 50. You can leave it as root 50 or 5 root 2. Now, if you look at the next example, you have the point P that has coordinate -2, 4. The point Q has coordinate 6, -4. So the point R has coordinate 3, -1. Show that the 3 points are collinear. Well, because of this idea of collinearity, I will try to solve. I wanted you to test your understanding, but let's look at what we mean by collinear. Collinear means it means that the 3 points are all on the same straight line. They are all on the same straight line, right? So if they are collinear, the 3 points are all on the same line. So if we find a gradient of the line joining any of those points, they must be equal to each other. So we could show that they are collinear. So let's start with the gradient of the line PQ. The gradient M of the line PQ in this case is going to be, if you look at the line P, it is -2, 4. and then q is 6 and -4. So what is the change in y in respect to the change in x? It becomes -4, -4, right? It is -4 y2 minus y1, right? -4 minus 4, divide that by x2 minus x1. We are going to have 6 minus -2. So that becomes -4 is what? And then you divide by 6 minus. So when you have -4, -4, you're supposed to get -8. So what is -8 divided by 8? Because it is 6 plus 8. Minus becomes plus. So you are going to get -1. Let's look at the gradient of QR. The gradient of QR, change in y over change in x, QR is going to be -1, -4, right? Divide that by 3 minus 6. 3 minus 6 will give you negative what? -3. And what is -1? -4. That's supposed to be 3. So you have 3 divided by -3. So this is also -1. So they are collinear. Since the gradients are the same and Q is on both lines, the 3 points are collinear. That is what we want to prove. So you have to be careful in this, especially for Cambridge specifications. You guys, in examination questions, find will usually mean find by calculation. Find by calculation. Examiners will not be looking for evidence on the method used. So the examiners won't pay attention on the method you have used to find. You have to find by calculation. You need to ensure you show your method clearly, including labeling of the calculations. Example, when you write gradient of PQ, we should know this gradient -1 is for PQ. We should know this other gradient is for QR. Labeling, it is very important. Now test your understanding in the exercises given below. I can give you guys like 1 minute to solve question 2. Right, are you ready to solve? Test your understanding. I have included the answers to these questions on the link, and you will find them after the class. Now let's look at parallel and perpendicular lines. Parallel and perpendicular lines. Two straight lines are parallel of their gradient if their gradient are the same. Wow. So if you have two gradients that are equal, we have gradient 1. If M1 is equal to M2, then these are parallel lines. We can see, we can see from this particular diagram, the image we have, we can see from the diagram that the gradient of AB, -4 by 6 is -2/3, the gradient of the line AB. And then we can as well check the gradient of CD, the gradient of the line C and the line D. They are all equal. You will get -2/3 after solving the change in y in respect to the change in x. Right. So the lines are parallel as the two gradients are the same. That is the concept I want you to note. Two lines are said to be parallel if the two gradients are equal. Again, two straight lines. Two straight lines. Let's use a highlighter here. So when we talk about two straight lines, so two straight lines, right? Two straight lines are perpendicular if the product of the gradient is equal to -1. So if the product is -1, this will be a perpendicular line. What we mean is the product M1 multiply this by M2. These two gradients must be equal to -1. Right. So let's use this concept as we try now to find, to solve questions related to the lines, the perpendicular lines and the parallel lines. The point PQ and R, point PQ, R and S have coordinates -5, 5, -2, -1, 1, 3, -3, and we have -3 and 1 as it is indicated there. So we have these coordinates. So you are supposed to show that PQ is perpendicular to RS. PQ is perpendicular to RS. Okay, so let's look at the gradient of PQ. PQ, looking at the gradient, the change in Y over change in X. PQ, this is P. Q, and then we have our R. So we are going to take -1, -5, -1, -5. Divide this by -2, -5. Right, because it is Y2 here minus Y1 divided by X2 minus X1. So this is supposed to give us -2, right? You simplify that. Now let's look at gradient of RS. RS is simply going to be 1 minus 3 divided by RS, -3 by -1. Rest. That is 1 minus 3 divided by that, a half, right? You will get 1/2. Guys, use your calculator to confirm the answers if you get lost. I hope you are in class. Are you in class? Are you in class? Okay. So let's continue as we look at now. We are looking at, if you start with -1 in the numerator, you must also start with -2 in the denominator. It is very important so that you avoid getting a little confusion in your calculations. Again, we can look at now, we can use M with subscript PO, or we can call it PQ. To denote, this represents gradient of PQ, right? Such that we multiply this gradient of PQ with gradient of RS. You multiply these two gradients. This becomes, our gradient of PQ is -2. Multiply this by what? A half. So what is -2 multiplied by half? -2 multiplied by half? Correct, -1. Right, -1. Therefore, the line are perpendicular. Correct. The line are perpendicular line. So look at the next example, example number 5. you can see the solution to the previous question. It is a perpendicular line. Let's quickly look at example number 5. Find the gradient of the line that is perpendicular to the line with the gradient. So here you are given the gradient. Since m1 times m2 will always be equal to 1, m2 will be equal to what? We know that m1 and m2 is -1, equation of the perpendicular line, right? And we know m2 will be 1 divided by m1 that we have, such that for us to find A, which is 7/3, since we know that m2 is equal to -1/m1, and we know this because m1 by m2 is equal to -1. So we simply take the reciprocal of that function. So A is 7/3. This becomes what? This becomes -3/7 as the answer. Change the sign and invert the function as the answer to the question. B, we have negative, B is negative what? This is simply question A. B is -1/5. -1/5 becomes +5/1, right? And what is 5/1? It can be simplified as 5. And then C is 1. So what is 1 then? It becomes -1. Because if C is 1, this implies that we can have it as 1 by -1. So this is simply 1. -1, right? And then D is -8. So it becomes 1/8. So this is simply what you will do in terms of finding this gradient of the line that has those equations. So look at example number 6 and try to do that yourself. You are supposed to find in each case whether the line are parallel to each other, perpendicular to each other, or neither. I can do the first one and then you do the remaining one. The first one we are having the equation A, y equal 5 minus 3x. Y, and then we also have y equal 3x plus 4. Right. So the gradient is equal to the constant of x. So let's look at the gradient here. In the first equation, the gradient is supposed to be -3, where you find x values. That is the gradient. And the gradient is this one is also +3. So m2 is also +3. So this is the gradient and this is also the gradient. -3 and then we have +3. The lines are not parallel or perpendicular. Yes. Because for the line to be parallel, m1 must be equal to m2. Right, we know that. And for the line to be perpendicular, the product must give us -1. m1 by m2 supposed to give us -1. So the line are not parallel or perpendicular. So use the same concept to solve B and C and check your answer in the link below after the class. So now let's look at those exercises I have included in the video and try to solve that. These are the exercises. Check them out. Check the exercises out. And we are going to conclude the class with the equation of a straight line, so that in the next class we are going to now continue with circles. So equation of the straight line. We know conceptual understanding. We know that the equation of a straight line is given by y equal mx plus c. And in chapter 1 and 2 of this P1, I have explained in details different kind of equations. Linear equations, quadratic equations, cubic equations, reciprocal equation, among others, even exponential equation. So we know that equation y mx plus c is the equation of a straight line, and m is the gradient, where c, m represents the gradient, right? And c is nothing but the intercept, y-intercept. So that is y-intercept, right? We can find the equation of a straight line when given the gradient and the coordinate of a point on the line. So if you are given the gradient and the coordinate of a point on the line, you can find the equation of a straight line, right? Let's consider the line passing through x1 and y1 as it is indicated. We can find the gradient by using the formula that I introduced earlier. Y minus what? y1 divided by x. So we can have x minus x1. And this is equals to the gradient m. In other way, we can simply say that y minus y1 is simply equal to m into x minus x1. So this will help us to find that gradient, to find the equation that we are looking for, right? So the equation of a straight line through the point x1 and y1 with the gradient m is going to be this, y minus y1 into m by x minus x1. And we can compute this and find the equation that we are looking for. So let's quickly look at the examples. Find the equation of the line through the points -2, -4, and -4, 1. Give your answer in the form ax plus by plus c equals 0. So you leave your answer in the form ax plus by plus c equals 0. So we have, so let's let the point that we are given, -2, -7, to be equal to x1 and y1. And then we can take -4 and 1 to be equal to x2, y2, right? Such that we can have y minus -7, right? Divide this by x minus -2. So this becomes what? This becomes 1 minus -7. 1 minus -7 is simply 1 plus 7. And then we have -4, -4, -2. So we are going to have 8 divided by -2. So this is supposed to give us what? -4. So y plus 4, equation of the line, will be equal to our gradient -4 into x plus 2. Right. So when we open that up, y plus 4 will be equal to negative 4x negative 8. That's correct. Such that we are going to have 4x, take the 4 to the other side, 4x plus y plus 15 is equal to 0. The required solution. So correct that, just a little error. This is y plus 7 in order to get 15. 7 plus 8. 7 plus 8, that is 15. We are given y plus 7. Y plus 7, not y plus 4. Y plus 7. That's correct. So the required solution is 4x plus y plus 15 equals 0. And it's as simple as that. Try to solve the other equations where you are given 1 or 2 points and you are supposed to find the equation of the line. So you have question example 8. Solve that and check if the equation of the line is 2x plus 5y plus 7 equals 0. Follow the steps and check the answers provided in the link below this video. So this is exercise 3.3. Try to solve this exercise and check with your answer. I want to believe you are able to solve these questions, especially question 10, 11, and 12. I want all of you in class to solve that questions and submit the answer in the workbook. I shall be marking that in our next class as we continue with circles in the next class. And this video will be available for you to revise as you also check the answers in the link below the video. See you in our next video.